Hey guys, how we doing?
We're back.
Yep.
8.2.
Section 2, Chapter 8. Talking about polygons in general.
Yep.
Is the chapter. So hopefully you caught all the different names for the different sides of polygons and so on with the different number of sides. But now we're narrowing our scope to just really a specific type of quadrilateral.
Yeah.
Again, it would be good if you knew, caught the concept that just a general quadrilateral is any four-sided shape. Don't limit your thinking to a square or a rectangle or whatever. It's just a general four-sided shape. So we're talking about parallelograms here, and there's a picture of one here, and I don't know, I tell my students it's just a squished rectangle.
Yeah, that's what I say. Somebody sat on it.
Yeah, it's just bent. The angles are bent over, but it does not change the fact that the sides are parallel. And so that's the definition of a parallelogram. Both sets, both pairs of opposite sides are parallel to each other. Now, it's impossible to have all four sides parallel. That's not what that's not what it says. Okay, but PS and QR, the two right-hand and left-hand sides are parallel. Top and bottom are parallel. Okay, and I know at least in my class we kind of cheated with that little symbol in front of the PQRS. We kind of used that before as just meaning any general four-sided shape, and that's not what that symbol means. It really means parallelogram, PQRS, and so it's kind of specific. And so one thing about labeling, I know this is a detail.
No, I was going to talk about it if you weren't. Yeah.
Yeah. You got to be careful about this because you know what? And it seems like even the book is not real careful about this. But the correct way of labeling any shape like this or any polygon, as we should have maybe talked about in the last one, is that once you start somewhere with a letter, you have to go in continuous order from that. You can't just jump. You can't call this P, R, S, Q, any order you want to go in. Once you start somewhere, either go clockwise or counterclockwise. Usually we go clockwise from that point. And usually we start with the first letter alphabetically.
Right.
That's just notation. And so that's why this is called parallelogram PQRS, because it goes PQRS around the shape. Okay? It's kind of a detail there, but it's an important detail.
Right. I mean, when we look at some similar polygons, maybe at some point,
right?
It's the same corresponding things. If you don't have things going in the right order, then you're just going to mess yourself all up.
Yeah,
so labeling is really important, guys. It's the semantics of this class that are really important to it. So.
Yep. Detail there.
Yep.
Okay.
All right, so parallelograms have opposite sides that are congruent, and parallelograms have opposite angles that are congruent. Now, these are the rules of a parallelogram. That's what makes it a parallelogram. Opposite sides and opposite angles are congruent. And so if you look at this picture down here, you have side JM and you have side KL, and those are congruent to each other, and you have side JK and side ML that are also congruent to each other, and notice that they are also the parallel sides to one another. And then if you look at the angles, angle J looks like it's more than 90 degrees, and angle L also looks like it's more than 90 degrees, and so we could assume that those are congruent. And angle M, it looks like it's less than 90 degrees, and angle K looks like it's less than 90 degrees, and so those are also congruent, guys. It's the way it is. And remember, a quadrilateral is bound by 360 degrees, and that's going to be important here. Just like a triangle is bound to 180, a parallelogram is bound to 360. So, anyways, to go about doing this, if we take let me see which one comes up first, the sides, we would just set them equal to each other, and now you have just a basic algebra equation. I mean, you guys should be able to do this no problem. I mean, this is pretty much a step back, I think, in a lot of ways from what we were just doing. So, you just move some things around. Move your x, you get 2x. Move your 4 to the other side, you get 24. 24 divided by 2 is 12. And so each side, JM and KL, are both 12. The equations may look different, but they mean the same thing. And then
the x is 12.
Yeah, the x is 12. Excuse me, my bad. And so if you plug it back in, then the sides would be 32. And so, anyways, but then you look at the angles, same thing here. Those two acute angles are congruent. And so all we're going to do is say 2y equals 78. Divide by 2 and you get 39, and so y equals 39, and that's pretty much it. But remember, I mean, it's actually 78 degrees, but y is 39. I mean, it's pretty basic here, guys. This is something where a lot of times if they look like they're the same, they probably are.
Yeah.
I mean, just use some common sense when you're going about doing this.
Yeah, just the whole opposite concept there. Opposite sides, I guess, is pretty easy to see.
Yeah.
Opposite angles might be a little bit more harder to see or whatever, but but they are just opposite from each other, the opposite corners of each other.
Opposite corners.
So, okay. So another property of parallelograms, so we have our first two properties that opposite sides are congruent, opposite angles are congruent. Our third property is that parallelograms have supplementary consecutive angles. Now consecutive angles would be angles that are adjacent to each other. So instead of the opposite ones, instead of opposite corners, if you pick any two corners that are right next to each other, then they are always going to add up to 180 degrees. And this diagram shows why is because if it's a parallelogram, that means that the sides are parallel. So as we take those and cut those with a transversal, which would end up being one of the other sides, those two angles that get created there, that are marked here by the 3y minus 10 and the 2y plus 30, those are consecutive or same side interior angles. And so from our talk before about parallel lines, what was that, chapter 3? We know that same side interior angles are supplementary. And so angle A plus B is 180 degrees, angle A plus D is 180 degrees. Any pair next to each other always adds up to 180 degrees here. So again, just like the last example, you can set up an equation here. Take 2y plus 30 plus 3y minus 10, set that equal to 180, and then solve that equation for y. And if you do that, y ends up equaling 32. Now guys, we're getting to the point, as Mr. Bedella was saying, that those algebraic equations need to be just secondhand to you now. You need to be able to solve those by now. So we may not go through all the detail in the slides of solving every one of those equations. You just need to be able to do that on your own as long as you can figure out how to set it up in the first place. So, but in this one, y would end up equaling 32, and that would make those two angles supplementary to each other. Okay.
All right, now another rule for parallelograms, and this is one that you got to really pay attention to your details here, guys. It says the diagonals of a parallelogram bisect each other. Okay, now one of the things that I see kids mess up with here is they think just because they bisect each other, that means that all four have to be congruent, and that's not the case. Look at the drawing here.
There's no way that could happen.
Yeah, look at the drawing and look at our hash marks here. You see that 2n plus 1 is 17 have one hash mark apiece, so those two are congruent. But then the WS and the S to Y, those each have two hash marks. So remember, 1 is different than 2 there, and so you got to be real careful. Yes, they cut each other in half, but not all of those halves are congruent to each other, if that makes sense.
Well, again, if we go back to our whole squished rectangle thing, there's no way the length of ZX here is the same as WY. One of them's way longer because it got squished that way. One of them's way shorter because it got squished that way. So how could the halves of them all equal each other? That's impossible.
Right. I mean, there's another quadrilateral, guys, where that might be the case, but right now, just the directions of a parallelogram are pretty simple. Opposite angles are congruent, opposite sides are congruent, opposite sides are parallel, and that the diagonals bisect each other. And those are some rules that we want to just keep bringing back. So if you look at this, to figure out n, well, we know that 2n plus 1 has the 1 hash mark, 17 has the 1 hash mark, so we know that those are congruent. So we just set that up, move things around, minus 1 divided by 2, and n is 8. Now, to find Sx here, okay, all you got to do is realize, well, if Sx is the same as Sz, I don't really need to go back and plug this back in. I can just say, Sz was 17, so Sx must also be 17. And then Xz, okay, would be the whole distance across, guys. So if one half's 17, then the other half's 17, just add those together, and you get 34.
Yep, those are the kinds of questions you're going to be asked. So.
Yeah.
Okay, guys, so here's just another example. We're going to look at finding all the angle measures, all the missing angles in that top parallelogram. Ignore that other box for right now. That's for the next example. We're just looking at that top box there with that parallelogram in it. So we're going to mix some things with triangles and the properties that we just talked about with parallelograms and try to find all these missing angles here. Okay? And so actually I'm going to have them start coming in here. And so as we look at just the center point there, the J in the middle, all those angles that are adjacent to each other in there have to be supplementary to each other because they make straight lines. The one opposite the 60, the vertical angle across from the 60, has to be a 60. And so that's where they're coming up with all three of those other ones. So the 60s and the 120s are supplementary, and the 60s and 60s are vertical to each other. So, okay. Once you know that, I think we're going to go to angle H over here. Once you know that, then looking in that triangle on the left, right? Yeah. So the triangle on the left is going to give us 85 degrees plus 60 degrees is 145 degrees. So that gives us the angle H down there to be 35 degrees. The bottom angle in that bottom triangle we have 120 degrees and 45 degrees. It's 165 degrees in that triangle. Subtract from 180. That's why that other angle H down there is 15 degrees. And we're just going to continue to move around that. And so if that 45 degree angle there in the bottom right hand corner is 45 degrees, then we'll use alternate interior angles. The top line EF and the bottom line HG are parallel to each other. We're cut by that diagonal as a transversal, and so those are alternate interior angles. So if that's a 45, that top one has to be a 45. We could do the same thing on the other side, use the HF as a transversal, and so the other angle up there is 15 degrees. And then going the opposite direction, the FG and the EH, those all end up being alternate interior angles as well. Okay, and so you just kind of work your way around the triangles, work your way around the fact that it's a parallelogram in order to come up with those different measurements for all those angles there. All right. Not sure that we really used a lot of the properties of parallelogram there, though.
No. Well, I mean, I guess
kind of broke that up.
Yeah, I mean, you could go back and check, and you could say that, okay, well, 45 and 85, if I add that with 15 and 35, it should add up to 180 degrees.
That's true. And add those together, it should be the same as the opposite angle across from it, so the other part would have to be 45 and so on. So,
yeah, I mean, so you can look at some of that and figure that out, but more than anything else, they're just trying to bring back the transversal rules, I think, more than anything else here.
So more than one way of doing those.
Yeah,
but,
yeah.
All right. Looking at this diagram now of the parallelogram OPQR, put within a quadrant system now, okay, intersect at point M. And the question is, what are the coordinates of point M? Well, what did we say 2 slides ago, was it? The fact that the two diagonals bisect each other, or the last slide. And so if the two diagonals bisect each other, then you could just find the length of one of those and actually find the midpoint, because they bisect each other. You could find the midpoint of either one of those two diagonals, and that would give you the coordinates of that point. And so you got to remember the midpoint formula. So the midpoint formula, remember, is the average of the x's and the average of the y's. And so if we take, I don't know if they spell this out for us or not.
They just counted on the graph.
They just counted it up. And so if we take point O and point Q and plug those into the midpoint formula, well, point O is at the origin, so they're both zeros. And so really it's just a matter of taking point Q and taking half of those. And so point Q is over 2 and up 1, 2, 3, 4, 5, right? So over 2, up 5. Add a 0, which doesn't do anything to them. Take half of each one of them, and it would be 1 and 2.5, or 5 halves. So that midpoint, the coordinates of that midpoint would be 1, 2.5, or 1, 5 halves. Okay, it's just the midpoint of that segment, that diagonal. All right? So just a couple examples there of some things that they might ask you about within some of the assignments on this section. All right, guys? Okay, we'll see you in class.